Welcome back to the Integrate Intelligently podcast. I'm Jeff Brickler, as you all know. Welcome today with my brother again, founder and CEO of CADTALK. Scott, man, it's a Friday. We're recording this, so definitely at the end of the week. How's your week been?
Oh, it's been really good, really exciting. Lots of stuff going on in the company and in life, and just got a cool weekend planned. I'm gonna play some golf. I'm heading up to Columbus, and I think I'm going to my very first Ohio State football game. So, yeah,
nice.
Yeah,
I guess having grown up in Ohio, it's probably shameful to say it's your first Ohio State game, right?
Yeah, well, we're from Cincinnati, so for some reason, like Cincinnati, like if you look at Ohio on a map, the entire state loves Ohio State football except for Cincinnati, which is weird.
For Cincinnati.
Yeah, so it's kind of a weird anomaly here. But my wife is from Columbus. My wife's from Dayton. I'm sorry, and so they're huge Ohio State fans. And then my business partners in Columbus, things like that. So yeah, I'm gonna check it out, and I'm looking forward to it. My the first college football game I went to was a Notre Dame game, and which is actually really cool. But I hear Ohio State's I hear the tailgates are really cool, are really wild.
Yeah, I know when I was there for my graduate degree, when I was on campus during the games, you just did not go to campus. You just, and even, I lived within walking distance by like 10 or 15 minutes. Even parking that far away, like where my area, people were parked everywhere, every street, everywhere. It just was a madhouse. It was such a state away. Because it holds like 100,000 people, right? And then there's a tailgating and all the things around that. And of course, students would sometimes behave badly and like burn couches and stuff if they didn't win. So that's good. I think it'll be fun. It'll be good. I've never been. I spent 2 years there, and I never went. So that's probably sacrilege. Just never went.
Yeah. Well, yeah. It's like you said, when you were there, that's when they won the championship too. It was like 2002 time frame.
I was there.
Yeah, 2002. They won the entire. I remember watching that game on TV, and you were still. I think you were just graduating or getting ready to graduate right about that time. So we're definitely aging ourselves now. So
I know, right? People doing the math.
Yeah, exactly.
Yeah. Good. Well, today is another educational episode. I love these educational episodes. The nerd in me, the teacher in me as well, loves to educate and talk about what I know and share that with other people. And so today we're doing we would talk about alphabet soup. One of the things I remember when I started in this industry was all the acronyms, all the different words, and all the different vocabulary around the business. I always used to say it's like a foreign language almost, right? It was English, but it wasn't. So I remember thinking when I first started applying my language skills to learning all these terms, because the vocabulary is so important. But to any subject, right? Learning that vocabulary is so important because it's hard to have an understanding if people are using words you don't know. So today's word of the day, if you will, is PDM systems and their relationships to CAD systems, right? And just as a reminder, CAD is computer-aided design that we talked about in an earlier episode, and different softwares there. And then PDM, Scott, make sure I get the acronym right. Maybe I'll let you define it so I don't mess it up.
Sure, it's product data management. So I think we did another episode about PLM, product lifecycle management, but the PDM is product data management.
Yeah, and I think in that last episode of PLM, we kind of touched about the differences between a PLM and a PDM, and sometimes they're combined, but they are separate software packages, and they're not interchangeable. I think a lot of people get confused and they think they're interchangeable, like, oh, PLM, PDM. I think, no, they're not the same thing. They do different roles, each important. Now, so today, that product data management and CAD. So can you give us a little kind of brief introduction of what does a PDM, right? What does it do? What is it? What's the purpose of it?
Mm-hmm. Yeah, I think that you see an evolution in the marketplace of like CAD, then PDM, and then PLM. So I think you see some overlap in some of these things because the PLM is I always think of PLM as being the next natural extension of what PDM was doing, right? But So if I talk about the history of these things, like when things first came out, there was CAD, obviously computer aided design, computer aided drafting is what I think actually started.
Mm-hmm.
Then you started creating all this kind of digital files, and you had all these files that you had to manage them, right? And then and then you figure out like, and then a lot of times they're just sitting on like, directories and things like that, and people trying to find them and version them and all that kind of issue. And the problem when they went to 3D modeling, so when you had like solid, like when you had AutoCAD or just a 2D, it'd be like a drawing, maybe multiple page drawing or something like that, for a given assembly or something like that. And then that was kind of hard to manage, but it wasn't easy to search it. It wasn't easy. It's just in like files in a directory. And then when you went to 3D CAD and you had like all these different files, and then they were interlinked together into assemblies and then managing all of those different files and how to search them, all that became troublesome because the file system wasn't really good at like some of the things it doesn't act like a database, right? So a database is very searchable. It's easy to organize the data. It's help, things like that. So the product data management, at least my understanding of it, I've been using some kind of PDM since I was an engineer back in the late 90s, is a way to organize that data of the product and all those files. So typically it has some kind of, they call a vaulting system around versioning, and a way to like bridge the gap between files and data. So you want because all the CAD data tends to be files that you're managing, but you want to be able to search, and you want to be able to know kind of what version's the right version, where things are. So think of it kind of being like a database that manages all the files and all the interdependencies and all of that. That's what product data management does. And it kind of evolved out of that problem, like most good solutions do, of like, how do I got all my designs. It used to be on paper, and we had some kind of card, like microfiche system. Like I remember my old company, we used to have, they literally had they would do a drawing, and then they take a picture of it and then put it on microfiche, like the old microfiche, like images. And then they had a card catalog, and they pull all these things out of a card catalog. They put it on a copier, and then they would copy it. It would shoot it basically create a photocopy of a little microfiche and make a big drawing out of it that you could use for the floor. And then eventually, when everything got digital, they put all that into a digital database of like PDFs or TIFF images. But then same thing happened with when you started doing digital drawings or digital models. They had a way of organizing it. That system grew out of the PDM, kind of grew out of that need to be able to search and work with that data that was just basically exploding, and so the organization became an issue over time.
So it's like dating yourself. It's like a card catalog a little bit.
Yeah.
Have a card catalog for all your digital files, right?
Mm-hmm.
A system for organizing that, centralizing a place to look, right? Because you have all these records, if you will, of files and how they're interrelated. Because a lot of times in CAD systems, to do a design, you have multiple parts or an assembly, and those have lots of files to them because each part is a file, and you take a bunch of parts together and build it up, and they're all interrelated on this assembly. And then you might have that exploded out. So you could have hundreds, maybe thousands of these files in all these different places. So it'd be very difficult to manage all of that. And where the file is located matters. If you move that file, then you'll break the model, because the model is looking for all the locations, right, of where the definition of that design is, that part. And
the 3D modeling really, really pushed it. PDM even existed before 3D modeling. Even there was actually a product we used to use called Auto Manager at Jones back when where the company I worked at before, years ago. And that company, even with AutoCAD 2D, even though there's not as much as file associations between files with 2D, you couldn't search. They had a 1 million part database. So or hundreds of thousands of parts, at least in AutoCAD, and just finding something was really hard, because it's just, how do you search files, right? And then so Auto Manager would just basically, almost very similar to how PDMs work today, it would extract like certain data out of the 2D drawing and put it into a database record. So that where therefore you could search across that database easily and find the file that you needed. And that was like that Auto Manager was a form of a PDM, just a very rudimentary one that only worked with 2D. But once you started exacerbating that by saying, now we have these 3D models, and you have models that are being shared across different assembly designs and all this stuff, that become it exacerbated the issue even more. Just because otherwise you could then you add the versioning to that, like what version of the thing am I using, and making sure I'm using the right version in this design and that design, and there's only one of them. And if I make an engineering change to this design, does everybody see it? I mean, all of those issues that kind of stem from managing the files is where PDM really shine. That's what it was. That's what it comes out of that problem is trying to solve.
Yeah. So I think, centralizing that data and then organizing it, making it easy to manage. That's what we call like the document management. Mm-hmm. So that's the original use case. It makes a lot of sense because now I think even operating systems in some ways are a data management, right? They're not PDMs, but even like Windows or Linux, they have ways to search and archive and index your files, right? And have properties about your files. Why would someone have a PDM system? Like, what are some other reasons you'd have a PDM system rather than, because Windows and Linux and others, like file systems, are much more sophisticated than they used to be. Why can't I just put my files on Windows, and then a lot of times Windows can search and there's properties about them. Why would you get a specialized piece of software if Windows has some of those capabilities?
I think it has to do with you could. I mean, there have actually been some companies who've done that. They'll use Windows operating system as the basis of the PDM. They actually will do that. So there is some capability there, because there's a thing called, from a technology perspective, called Windows Search, that you can index the data so it's searchable through like regular Windows search and stuff like that. There's ways to do that. But as the operating systems have become more, but that's very much a feature of that operating system, right? And then you have to so as things become more web-based and more cloud-enabled, it makes more sense to have those things be more their own applications, and then the indexing and things like that become more proprietary, or that way more proprietary in the way they build them out for that purpose, and also more standard as far as using web technology versus any given OS, a different operating system. But another analogy that you see a lot out there, there's very much an analogy between source control for code and PDM.
Right.
So like Git being a very popular source control. I mean, there was CVS. There's a couple different ones, CVN, I believe, and SVN Subversion. There's a bunch of different ones, but Git being one of the most popular ones now, it also does the same thing. It works with file-based data, it tracks changes and revisions. It's a little bit more, it's on text-based. With text, you can do a little more advanced things with like merging and things like that. But in effect, PDM in a source control system work very similar. Both are working around how to manage an intellectual property of code versus or text, IP versus design IP. The design IP tends to have more, an intellectual property, it tends to have more complications, because you can't like if I have a text piece of code, I could take, if I made, say, two different engineers made changes to the same piece of code, there's a way to merge those changes together into one text file. You can see the code and you can kind of make a decision. You can't really do that with designs easily, right? If I'm an engineer working on a bracket, I start working on it, and then you're somewhere else in the company, and you're like, well, we need to change this bracket and add another hole to it, and you grab that design, put a hole into it. There really isn't, the technology isn't easy for me to merge your holes with my changes and make a different one. You can do that with code because it's just text, but it's hard to do that with actual physical models and things like that. So typically what you see in a PDM is more they call a locking mechanism, which means when I pull that design out to then change it, it also has a capability to lock that down and say it's being revised, almost like checking out a book from a library. And with code, we don't have to do that because we can merge. But since the merging is hard, we actually have to do what we call a locking, kind of checking the book out. So you check out the design and say, and then it usually records, this engineer is making changes. That way another engineer doesn't try to make changes to the same design, and then we don't have that kind of a problem because the merging is so difficult. So there's also that capability with PDM to kind of gate check changes. Because if you're an engineer to order company, I mean, you think about where I came from, when there's 3,000 new parts every month and 3,000 engineering changes, it is very possible two engineers could try to change the same thing at the same time, and dealing with that. So you want to have a system that manages that. And once you enable that, it actually opens up a lot of different workflows in the company as well, which is an interesting kind of side topic. Was like, because now because you have a database, the PDM is tracking the fact that there's something happening, right? Like, as opposed to just like a file being on some engineer's computer, they open it up and they do the work on it. Nobody really knows until he decides to tell everybody. You can, like, there's a system that is going to and saying, telling everybody, I'm going to change this. And he checks it out. And we actually had it tied when I was in manufacturing. We actually tied into those PDMs and notified the manufacturing plant. So we actually had this thing on the shop floor. It's kind of an interesting side story. We actually had this thing on the shop floor called a dispatch list that listed all the work that had to be done. And then because of the amount of changes in this engineer to order company, a lot of times they start making parts, and then the engineer will be revising that part while it was still in production because they'd find a bug or something wrong with it or something like that. So we literally had this live dispatch list on the shop floor that would when the engineer checked out the design from the PDM, we would actually tie into the PDM and then flag that in the dispatch list on the shop floor that part was being revised. And they might set that part aside, or they might call the engineer and say, "Hey, what are you changing before I make this? Because I don't want to scrap this part." And by having these kind of systems set up like that, you could actually tie that together, because now it's once again, like we talked about during the ERP episode, it's a communication device too.
Mm-hmm.
It's not only is it managing the data, but it's also communicating the data to the organization.
Yeah. So it handles that revisioning, right? That control, and then communication, and prevents people. So it sounds like one of the benefits of having a PDM is communication across the organization. And then also having a nice process. You talk about changes. So I'm sure PDM systems help with those changes by tracking them, but also I imagine revisioning the parts, right? So after you finish them, you check it back in. I imagine a PDM system might say, "Hey, this is a new revision or new version of it."
It is, yeah. Like engineering change management, which we like, or engineering change control or orders. That's where like some of the PLM stuff started coming from, right? You have more like you'll see some engineering change kind of processes built into some PDMs like Vault or SolidWorks PDM, and you start seeing those, but then you start getting, if it gets more advanced, it starts falling into the PLM world, right? And then you also have things that are in the ERP side as well, but yes, that versioning and keeping track of the files and locking the files, things like that, is definitely in the world of PDM. Of course, the next step is how do I communicate those changes out, which is then starts to being more like PDMs can do that, but also more of a PLM type of scenario that happens with. But yeah.
So you dropped some names out there. I mean, what are some of the PDM systems that we work with or that you've seen through the years? Some of them probably don't even exist anymore.
Sure. I mean, the one that I started with, I mentioned Auto Manager, which is like the old school AutoCAD one that we had. That was, I think, from the late '90s, the 90s, and then there was the one I used. We implemented back when I was a Solid Edge user. We used a product called Smart Team, and Smart Team was actually, I think it was out of Israel originally, and a really cool product we were implementing there that worked with Solid Edge, and it was a PDM. It did all the data management there. There's another product that came that I think it was called, obviously there were some, I think Team Center is more of a PLM, but it has some PDM features in it. A lot of times PLM systems will have a PDM component. I mean, Windchill is kind of both a PDM and as well as a PLM, depending on what version you buy and things like that. There's SolidWorks PDM. There's Vault, which is an Autodesk product. There's also just third-party ones that are out there as well that that you can get, that are third-party. Being, when I mean third-party, being they're not related to a specific CAD systems. So you think about it, a lot of these PDMs would have grew out of the need from the CAD vendors. So the CAD vendors created these tools, and they figured, it's hard to manage these things, all these files. Let's create another tool that manages it. So then there was third-party people who said, well, I could build a better tool to manage these things. And then we could also be CAD agnostic. We could say it'll work with all the different CAD systems, not just the one that's for that vendor. And then a lot of the vendors followed suit. That's why, like, if you have Autodesk Vault, it can still manage SolidWorks files and Inventor files and AutoCAD files. And so can SolidWorks PDM, can SolidWorks PDM can work with Inventor. So like all that stuff kind of consolidates over time. And then you can actually put like Excel files and things like that in there too. So so basically it just comes into being file management and then kind of associations around that but but they're not. I wouldn't confuse them with the document management tool. It's a little bit different, but because there's more data typically around those associations. So like we get, I guess, is a good point. We get asked all the time about whether or not you could use customers who don't have PDM, they just have CAD, and they're buying an ERP that has document management. And they're like, well, why can't I just use my document management to do the PDM thing, the PDM role? And it's just like not the right tool for the job. It's similar, but not exactly the same. And that idea of the check in and check out is, you'll see enough overlap where it can be confusing. But typically, the problem is the tooling isn't built around making that easy.
That's right.
Right. So you end up having to do a lot of things that are clunky to kind of make it work. And then what we find is with processes that, like, most people, like, if it's not easy enough, if it's not seamless enough, then people don't adhere to it very well. Whereas, like, in the case of SolidWorks PDM or Vault or these other tools, the tooling around the tooling between the CAD and that system is so smooth that it feels seamless. That's why the adoption goes up, as opposed to the more friction you put between the CAD and that document management system, the less use case, the less accurate the data. So yeah.
So to that end, it would make sense that the publisher, so like the publisher of a CAD system would produce a PDM, and that PDM could work with all kinds of different files, but probably works best with the files that it produces. So like SolidWorks has as a CAD system, and it has a PDM, SolidWorks PDM, and different versions of PDM that you can buy. Works best with SolidWorks files. Yes, it supports Autodesk and AutoCAD and a whole host of other CADs, and it can do all of those things, but it works absolute best with SolidWorks because they built it for that very reason, right? Same with like probably with Windchill or Teamcenter, or even with Vault or any of those, where they're designed for their system, right? Their CAD system, because the CAD system is kind of, it's kind of like PDM is a little bit like a vault or like a bank safe, right? You're going to put this document in there, you're going to lock it down, and then of course I always thought of it like as a safe with a digital like banner across the top. You put this thing in there, and it goes thank you, and it locks it down. You can't open it, right? You don't have the key, you don't have the code or whatever. Then across the top, it just tells you what's in there, right? It's like, because you can't see it. It's like, this is the part number, this is the description, this is when it was revised, this is the current revision, this is who did that. Here's some other information about that, right? So you can see all of that without having to go into that vault and then pull out the similar, like if you had put in a vault, you could see a counter of your money, right? You have all this money, and you have this many 10s, this many 20s, this many 30s, or not 30s.
Yeah.
It's not a currency.
50s,
not a currency.
Yeah.
50s, 100s, or whatever.
Yeah, so, it's a good analogy, because like it could work really well. I mean, your point's well taken. I mean, it depends on how easy it is. Like, because when you're pulling the file-based data, you're extracting you're extracting metadata from those files, right, to then index in that system, and then the extraction of that metadata has been somewhat standardized, but still, I mean, each of these systems can know how to do it, but they're always going to work better with their own stuff. Like, because it's the whole idea of vertical integration. Like in any kind of company, the more vertically integrated you are, typically the smoother things run. So good example of that would be like Microsoft versus Apple, right? Microsoft was an operating system for lots of different hardware, right? You had all the different IBM clones and all that stuff back in the late 90s and 80s and stuff. Oh, and that OS ran on everything, but you didn't always, like, some computers it ran really well on, others it didn't run so good on, right? And then so they sacrificed a certain level of in the example of Apple, they made all the hardware, they made all the OS, they used to make all the software. I mean, like, it was really a closed system, vertically integrated. Well, usually the experience on the Apple and all of that was superior, because it was just it's vertically integrated. You have all these pieces working together. So you're just like, well, and it's just very seamless. Whereas like, but it was less flexible there, because you don't have as much of an infrastructure to build things. So whereas on the Microsoft side, by working on multiple computers and then allowing their ecosystem to be opened up to partners, the breadth of availability of solutions went up, but the quality go down. So there's that kind of that battle with any given tool, right? It's like, what am I optimizing for? We say this a lot internally. People are like probably sick of me saying it. It's like, but what is your, like, when you're, anything you're doing, any problem you're trying to solve, you're trying to decide what thing are you optimizing for. So Apple's trying to make a very seamless experience across the board. But by doing that, you cut down on flexibility, but increased flexibility, you tend to make less optimal experience. The same thing with PDM or any tool. It could do something, doesn't mean it's the best at doing that thing, or it's been optimized for that thing. But typically when they're working with their own stuff, like we talk to people, they're like, well, what PDM should I get? And I'm like, what do you use? Like, what CAD do you use? And they go, well, we use SolidWorks. Well, I'd probably recommend SolidWorks PDM because it's built to work with SolidWorks. You could use Windchill, you could use it. It probably would work fine. It just depends on what you're optimizing for. Because maybe there's a feature in Windchill that you really love that does this thing that you want to take advantage of, and you're willing to sacrifice the fact that it doesn't work with SolidWorks quite as nicely as SolidWorks PDM does. But that you have to make that decision when you're weighing out the feature set. But my recommendation is, like, by default, like, we don't usually recommend anybody go with any given thing, but is usually a lot like what are the things you're going to use every single day, right? And kind of optimizing around those workflows, because those are the ones that you have to live with, and that's why when somebody says, hey, which PDM should I use? I would say, well, which CAD do you use, and push them to that direction, because it just tends to work a little bit better.
Yeah, I mean, of course, sometimes people want to have a PLM too, right? So, like, if they maybe decide that they want to use a PLM like Windchill or TeamCenter or other PLMs where it's also a PDM, but to your point, they may say, I want to optimize, I need that PLM capabilities. So yes, I know SolidWorks has an integration with Windchill, and that's probably a good integration, but it is not a native thing. I mean, it's built after to work with Windchill, versus Creo is built to work with Windchill directly. Yeah. And so it just depends, like you said, on what the need is. Like, what are you trying to achieve? You got to keep all that in mind.
Well, even with the consolidation of all these different companies, right? You think about, like, some of these systems buy other systems and stuff like that, and they're like, well, it's the same company. Like, you think that this product would work better with that product. And that isn't always the case, because they used to be separate things in the past. They got bought a couple of years ago, or that's not a focus for them to do that. So, like, you'd be surprised, like, even products like the CAD product in one company and the PDM for that same company or the PLM don't actually work together that well.
Right, because they're actually different softwares developed independently.
Yeah.
And then a parent company bought both of them, and now they're like, well, these things go together. You're like, well, they weren't built together. They were built separately, and now we're trying to put them together.
Yep.
Which you can do, right? People do it all the time. Softwares, they do it all the time, right?
That's what we do.
That's what we do, right? They do it all the time, right? And absolutely do it all the time. It's a very valuable thing, but a system has to do what it does really well, right? Mm-hmm. And I guess we get into the next thing. What we do is like integration. So typically, PDM systems do they have their own integrations to ERP, or what's the relationship? Would you integrate? What's the relationship between PDM and ERP, and, like, why would you integrate the two, or what is that?
Yeah, I mean, it's like the same thing that when we integrate the CAD to the ERP, integrated the PDM is, like, think about it, the PDM is just we're extracting certain data, right? And we're also indexing it in a database, right? So finding the data and getting it and retrieving it is a little simplified whether we go to a PDM, right? Because now you put a database behind it, and then you can, once you have a database behind it, you can create APIs and do things like that. So, like, when we integrate to CAD, a lot of times we're, like, opening up files and reading the data out of the files, right? And that's usually a more manual interaction. Whereas if you're doing PDM, all that data is now indexed and it's more searchable, and it just allows you to do more automation. So, like, CADTALK kind of exists on a spectrum of, more if you can do everything from manual all the way to completely automated, right? And anything in between, you have that spectrum, right? And the PDM would get you closer to that fully automated side. And then PLM as well does that as well. So because of the way that you interact with that system, you can do search is better, the finding things is better, that the organization is better, as opposed to just a bunch of files. And so that's typically where and then there's also the idea of data augmentation. Just like I can pull data from the file, metadata from the file, to then put in my database for PDM, but I also could add additional data. So that's just basically that's in the PDM itself, that isn't in the CAD files. for like additional searching or other attributes that you might want to assign to that you can use to then help with the ERP integration or to pull downstream. So sometimes people will put like vendor information or like or other types of extra data on what they call data cards, or basically the database record of the PDM about that file. They'll put some additional data in there that could help with the downstream integration with the ERP, because it just really depends on who has the information and what tool they use is the best place to store it. I think a lot of people are trying to like synchronize these things, and synchronization is not necessarily like we always talk about where's the master. It's like the master, we talked about this before, the master is whatever it makes sense for it to be, right? It could be, it's depending on what tool it is. So the idea would be like who's using which tool and who has the information for which that tool should store it. So like if the engineer knows who the vendor should be, then maybe they would put the vendor, we could put the vendor information in the PDM or something like that. But if it's going to be determined by a purchasing person who uses the ERP, then that should go in the ERP system. It has to go in the ERP system eventually, but where is it being derived from? Who's the person who's putting that in, who's actually indexing that? That makes the most sense to do at that point. And so there's some data that makes sense to put in the CAD, some data makes sense to put in the PDM, there's some data that makes sense to put in the ERP. Like our job is to make sure that it flows through from wherever it is to where it needs to be used. But essentially the source of the maintenance of it is, it could be either any of those systems. It really depends on who has the knowledge and what tools they use.
Right. Yeah, that makes sense. Yeah. It goes back to, I think, one of our earlier conversations. I get the question a lot during demonstrations, or even when I was working with partners, will ask, well, which one's the master? Which one's the master? And I always would say it's like it depends, right? It depends upon, like you said, like where, a design, a CAD system, it owns the geometry, right? You're designing it in that thing. No other system can own that. Like you got to make if there's a hole here or not a hole here, or if there's two holes, like the CAD designs that, so that's the master there. Mm-hmm. But there's this overlap, right? Like a Venn diagram. You have data that's shared with the CAD. Well, you kind of multiple Venn diagrams, right? You have CAD, then you have PDM, and there's like an overlap there. Maybe, and then of course, then on ERP or PLM over here, right? You have another kind of Venn diagram overlap. And so there is shared data. And I think the question always in integration and automation is like, well, that shared data, right? How do we manage that shared data? Who's the master of that shared data based upon your workflows and best practices?
Yeah. And it's like, and I think the Venn diagram example is really good. I also think about it more of like, there is some shared data, like people always bring it. The one that always people bring up is like description, right? The description is the same no matter where it is, but it really isn't. If you think about it, like its representation of the description isn't the same everywhere, right? So, like you might have a description, like in the CAD file that's, description is 200 characters long, but when it gets to the ERP, that field is limited to 50 characters, and therefore you have to split that description across multiple fields, and then somewhere else it might be, other, so I think of it like there's a shared source of data where it was first derived. It was first typed in by the engineer and the CAD system. That's the source or the master per se, but its representation where it's across those different systems is different. That's where the transformation comes in. Like, how do I take that source data and turn it into the way it needs to look or work in that other system? As opposed to saying we're sharing it. Yes, you're sharing it, but it kind of starts somewhere and then it kind of gets replicated in the form that makes sense, transformed into the form that it needs to be. But the source of it is that for a system which was maintained, right? It was initially maintained. So the design's maintained in the CAD. Maybe the description is maintained in the CAD. And some people debate, well, no, we're going to put the description into the ERP and then drive it back. There's all different kinds. It depends on what makes sense for that business, but that based on what is more based on where the data, like certain data, the source is the CAD, and some data, the source is the ERP, and some data, the source is the PLM. Like it depends on what the data and where it makes most sense to be the source. And as long as you have software maintaining that sharing or that transformation back and forth, then it's not really a big deal to manage that. But when it's like manual to keep all those things going, it's where you run into.
So what kind of obviously we do integrations with between CAD and some PLM systems, and and a lot of integrations between CAD, PDM, and PLM systems, those alphabets with ERP. But what kind of organizations? I mean, manufacturing companies. What size organization? How do you know you need a PDM? Because I talk to customers. Sometimes they don't have one, right, for one
Yeah.
reason or the other. So the question comes up. I get asked a lot. Do I need a PDM? It happens a lot, and then they want a recommendation. What would you tell someone when they said, "Hey, does our company need a PDM?" Or if you had walked into a manufacturing company today or designing and say, at what point do you know you need that?
Yeah, I mean, I think I kind of use and this might be a controversial take on this, but I would say that, like, I don't know if I would think a PDM in today's world is kind of table stakes, to be honest. I mean, I think it's pretty much it's kind of a standardized tool. People might disagree with me if you're one engineer who's just designing some, a handful of parts, for some kind of, like, you make a very repetitive product and you only have 5 designs. Those 5 designs being on a shared drive somewhere isn't a big deal, but it doesn't take long. If you have any kind of growth in your company, that you're going to have more than one person working on things, and you're going to have more complexity in your products. I mean, generally that's how things go. So if you're assuming any kind of growth, which usually involves more people, a PDM becomes pretty essential pretty fast. And they're kind of almost sold together anymore. Like, they're kind of come as a package. It's like you don't really see you see CAD come with PDM. So it's pretty much, I think PDM is pretty much table stakes at this point. Now, I know, as you mentioned, there's a lot of customers who still don't have PDM, and they're able to operate and survive. Like, they're just because it's something it can work doesn't mean it's ideal. It's just saying that it's the same thing with people talk about development, like, without source control. There's lots of code out there in the world that's being written that isn't in source control. But like, Git is free. I mean, you can go get you can use Git for free. So, what's the limiting factor other than learning how to use Git and do the thing? So, and the benefits you get from it are so good. Like, why would you not? So it's kind of like becomes table stakes. Like, it just becomes a level of sophistication to have it. And I kind of think the same thing about PDM anymore. But it might be a controversial take, at this point, but it's just,
no, it makes sense. And I think that there are different levels of PDM. Usually there's like a standard and a professional, and then and maybe an advanced. There's different levels. So to your point, like, unless you're just like one engineer, if you start wanting to grow and that team's going to get bigger, some form of PDM, I think I would agree with you. Like, some form of PDM is probably critical. Like, if you're going to do designs, even if it's like just the sort of the base level PDM that doesn't have all the features that you might want long term, I think it makes a lot of sense to have some kind of mechanism for that management. If you're doing any kind of designs, even if you only have 2 or 3 engineers, I think it makes a lot of sense. Maybe not buy the best one, the most expensive one, and maybe just implement like all the fancy features of it. But getting something going will be way better than waiting on it. Again, that could be a controversial take.
Yeah, I think of the same thing with, like, I draw a lot of analogies to the source control and coding and things like that. It's like, even when in very early days, when it was just me writing code for CADTALK, I used source control probably within the first 3 or 4 months, because and the beauty of that is I have a history now with the source control of everything that's ever been changed, and all that's there, even though it was one developer in those early days. And but still, I mean, same thing with, you get similar benefits with that kind of control with designs. Now, like, you don't have to have it, but it's like, it definitely gets harder as the team grows. It could be a limiting factor in the growth of the team. You're like, well, now I got two engineers, I got 3 engineers,
right?
And then you're trying to implement this PDM along with that, and it just becomes like, so it's one of those things, like, you might say, well, let's get this practice in day 1, and then you don't have to worry about it. You can scale the team easier.
And it's behavior change, right?
Yeah.
Because now you're you started one way, and now you got to change, and that, of course, that happens all the time.
Sure.
But if that's just cost prohibitive and outrageous, then I think it makes sense. So we're going to wrap it up, and one thing I wanted to ask about is, you've been in the industry a long time now, as is evident from your knowledge. Where is PDM headed? What's the next stage of PDM?
I mean, I think you're going to see a lot more, more merging of, like, some of these things into kind of one thing. I think more, you're seeing the lines already blur between PDM and PLM. They're kind of blurring more and more as things move forward. They become more commoditized. They become more standard of like I said earlier, table stakes. Like it becomes more of just a thing that like that's just part. It's a feature. It becomes, instead of being a product, it becomes a feature of a bigger product. I think that's what you're going to see more and more is you're going to see consolidation, and in like almost every industry over time, things get combined and rolled up and made into one big thing. And that's kind of how things go. And then, but yeah, I think you're going to see more and more of that, and you're going to see some changes. Like I think that you're going to see like the idea between, especially with the cloud and things, cloud-based CAD and things like that, you're going to get this concept that like there are no files anymore.
Right.
There's just database. There's just the PDM and the CAD are the same. So I think you see that today with like, what's the product? 3D
Experience at Dassault, and then PTC has Onshape, where
Onshapes like that. And there's another one with Autodesk.
Is that their that's Forge is like the platform. They have like Autodesk cloud services.
Yeah, it's like Forge is like it's basically built into the, what's the product? The CAD product itself. I'm blanking on it.
There's like this Upchain, right? Upchain is something.
Yeah. So I think you're going to see the CAD with the cloud and the data being in the cloud. It's just going to be like you're saving directly into the PDM, or it's all one thing. It's just there's a database, all the metadata. There's no point of file anymore other than distribution. So if I wanted to if I'm able to share things through the cloud, like you kind of get this kind of like Dropbox effect where it's all kind of being just there, right? And then because really the only benefit of like the file-based versions of things is for distribution across companies and stuff like that. So like it's the equivalent of being able to print out a piece of paper and send it in mail. You can send a file, and but you always can generate those on the fly. So do you really need the file until you actually distribute it? That type of thing.
That in the cloud is ubiquitous, right? So people can get to it everywhere. So you don't need that localized version anymore, right? You'll be able to just, like we do today, right? Even with Microsoft products, they're stored in SharePoint. That's what OneDrive is, right?
Yeah.
So it's a similar idea. Well, man, we're getting a little long here, I think, but PDM was a great topic. I think that some of the takeaways in my mind was like, should I have a PDM? Probably the answer is you're doing designs, yes. Some kind of hot take is that you should have one. If you're doing designs, you should probably get one. Either maybe not necessarily the fanciest one, but you should have one, and that. And then, of course, the benefits of integrating it to your business, right? So that's ERP or PLM can be very useful for shared data and doing those transformations. So anything else to say on the PDM topic? Scott, we covered, CAD and PDM and PLM. Those are the big kind of engineering pieces of the puzzle.
No, I think it's a pretty good, pretty encompassing, at least get all the acronyms out there. I think we actually even have a glossary and internally to teach everybody these acronyms. But I think we get more into some of the specifics of like certain use cases and things like that. And like, I think we were talking earlier about configurations and things like that would be an interesting topic. But I think that and there's all kinds of features once you start digging into any given one of these packages. But from an overall perspective, anybody's coming to just like, what the heck is this CAD, CAM, PDM? Maybe CAM would be another one we could talk about. Like an interesting one, like a CAM software, nesting software, things like that are always cool. But there's just a lot to learn about these different areas of manufacturing engineering that are super fascinating. And then to talk about. But I think these core three, PDM, PLM, and CAD, is a great place to start if you're just getting into this.
Well, man, I know I've learned a lot from you, even on this episode. So I continue to learn about this industry and about what our customers are doing. So, Scott, I really appreciate it. Thanks everybody for watching. I really really like to see the audience growing. So if you haven't subscribed, please hit the subscribe button. And listen to us anywhere you get your podcasts, and share this with your friends, share that with other people in the industry. Feedback could be good too. Comment, as they say with the YouTube, comment for the algorithm. So Scott, man, you have a good weekend, and we'll see you next week.
Sounds good. Talk to you soon. Thanks, Jeff.
All right, later.